Alrighty, hello geometry friends. It is time to begin reviewing for Chapter 7. So we've got first in a two-part series of reviews. This is the practice test, and then I'll also be making a video for the chapter review. But what I have up here is this page 508, 1 through 10 all is what you'll be assigned. And I'm going to work through the odd problems, 1 through 9. So let's go ahead and get started. Get my trusty calculator here ready to go. So we'll start with number 1. Problem number 1 is finding the ratio of rise to run, also known as the slope, between two different points. And so probably the quickest way to find the difference of those 2 points is to use the slope formula, which is m is equal to the 2 y's subtracted over the 2 x's subtracted, because y is your vertical axis or your rise with a ratio of x, which is your horizontal axis or your run. So we're just going to start with our 2 y's. So here's our x, y, x, y. So we're going to just start with our 2 y's. 4 minus negative 6 over our 2 x's. It's very easy to mix up your x's and your y's. So that's why you want to rise over run, y over x, not x over y. So we do now we're at negative 6 minus 10. Notice also I went from left to right and again left to right. It doesn't matter which order you subtract them, but if I were to do right to left, I'd want to maintain that pattern for top and the bottom. Either way, I would then get me the right answer. So 4 minus negative 6, I like to think of that as adding positive 6, the double marks. Subtracting a negative is the same as adding a positive because you're removing negativity, which is a good thing. So we get 10 over negative 6 minus 10, negative 16. We can now reduce that. That's a ratio of rise to run, but now we want to reduce that. Look at a number that goes into both of those. It's 2. So if I divide 10 by 2, I get 5 over, keep the negative, negative 8. That is now our lowest. We can't reduce that any further, so that is our slope. This line decreases at a slope of negative 5 over 8, or dropping 5, running every 8. So negative 5/8. Number 3, the question asks us to confirm that the 2 triangles are in fact similar to each other, and then to write a similarity statement. There's a couple marks here I forgot to include. It shows you that angle B corresponds to angle N, and it also shows you that C corresponds to P. That helps us to orient the 2 triangles the same way. But this is a very simple problem in that if they are in fact similar, then the ratio of one side with its corresponding side divided should give me the same number of another side divided by its corresponding side. And so let me show you what that looks like. So first of all, I'd probably identify the longest side of this triangle. That would be 66. So that means 66 over the longest side of this triangle, which would be 99. That will give me a fraction. If I put that into my calculator, that's going to give me 0.67, approximately 66666, wonderful number in the book of Revelation. Or this is the same as 2/3. Doesn't really matter. Now I just have to check, do the other 2 sides, if I do the same fraction, do I get the same 0.67 or 2/3 when I divide them? So I'm now just going to look at the shortest sides, because it's the easiest way for me to line up the right ones. The longest with the longest, the shortest with the shortest. So 40 is my shortest over here. 60 is my shortest over here. If you plug that into your calculator, or that one, you can see very also simply reduces nicely. You're going to get, again, it works, 0.67, or you can see that reduces to 2 over 3. So we're in business. 2 of the sides correspond. We have to check the third one just to be sure. So that leaves the middle side here at 54, divided by the middle side here of 81. Again, you could work your way just reducing that by hand, plug it into your calculator. It does, in fact, come out to 0.67 or 2/3. So we can confirm, yes, two triangles are in fact similar by a similarity ratio of either 2/3 or 0.67. You could express it either way. And then we have to write a similarity statement. So that means we have to name the triangles as similar in the right order. You can't just say any random 3 letters here and any random 3 letters here. If I say ABC, I'm going to do that right here, triangle ABC is similar, little squiggle there, I want to make sure I pick the angle that matches with A. And as you can see, that's why it's good to see that B goes with N, C goes with D. So A would be triangle M, B corresponds with N, so M, N, C corresponds with P, M, N, P. So that's a similarity statement. Triangle ABC is similar to triangle, it's not a very good triangle, M, N, P. And each of these correspond. It's not just a random association of the letters. So that's number 3. Go ahead and box what might be final answers. Okay, number 5 is a proof, but you'll see it's not that bad of a proof. The proof is that it asks us to prove that these 2 triangles are similar, and it tells us that this triangle, this shape here, RSTU, is in fact a parallelogram. And if you remember, in order to prove triangles similar, there's 3 ways. You can prove them using, let's go and switch colors again. You can prove similar triangles by showing that all 3 sides are similar. That's what we just did here. They're similar because we showed that all 3 sides have the same ratio. You can prove it by showing that a side, angle, side are the 2 sides being similar and the angle being congruent. Or, hopefully the one I always look for because it's the easiest, AA. You can show that 2 of the angles within the triangles are congruent, then you have similar triangles. And you're going to find out this is actually the easiest one here. One, you might want to trace these out so you can see them a little more clearly. There's our triangles that we're trying to prove similar. And I can see right away I have vertical angles. That's one reason I immediately jump on this one. So I can say, oh look, vertical angles are always congruent. So I know that this angle is congruent to that angle. Also, if they tell us that this is a parallelogram, that must be for a reason. And it probably is because you've got 2 sets of parallel sides here. So that means UV is parallel to TS. And if, as we've learned all year long, where there's parallel lines, you have alternate interior angles. So that tells me that angle S, if I look for the alternate interior angle, again, what I've got here is I've got 2 parallel lines. This SR line is forming a transversal. And so that means this angle is congruent to the alternate interior angle there. If I look at that angle, this is S. If I look over here, R is the other angle. So these 2 angles, angle S, must be congruent to angle R. That means now I've got 2 sets of congruent angles, so I'm going to be able to prove this congruent by AA. Let's go ahead and write the actual proof though. Statement, reason. Always start with your givens. They give us that you've got parallelogram RSTU. My reason for that is it was given to me. That is what allowed us to say then that UV is parallel to ST. I'm sorry, we'll say TS. And that is definition of parallelogram. That's my parallelogram symbol. Then that is what allowed us to say that angle R must be congruent to angle S. Corresponding angles. And then we can say that angle RWV, that's this one right here, RWV must be congruent to angle SWT. Notice the middle letter, the W, is the one we're kind of trying to prove congruent. That's because they are vertical angles. Again, vertical angles, whenever lines make an X, the angles on opposite sides of that X must be congruent to each other. So now I've got this angle is proven congruent, This angle is proven congruent, so therefore, triangle RVW must be similar to triangle, I'm running out of room here, STW by AA. Because I was able to prove that there were two congruent angles. Okay, so a little bit more work, but it's good to review that proofing process. And just remember, here's your 3 ways you could do that. They'll usually, AA is the one you'll see most likely on most problems.